Hello. So yeah, just when you thought it was safe, I am making another Simplify3D version 4 video. Now, way back when I did, well, it wasn't that long ago, but when I did the series, I skipped over the improved mesh reduction feature that is in version 4 of Simplify3D, and I got pulled up on it, and yeah, it probably was a little bit of a cop-out. I kind of briefly explain why I skipped over it. The first reason was that I never really used Simplify3D for any kind of mesh work, and the reasons for that are due to, you know, the kind of things that I end up printing. They tend to all be sort of very mechanical parts that don't really need any mesh reduction. And yeah, in the rare cases where I do need to work with meshes, I do it all in Mesh Mixer, just because I'm kind of normally having to stick two different meshes together, so I have to do that in something like Mesh Mixer, and yeah, so it makes sense to also do the mesh reduction in there. Plus it's more flexible, blah 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 blah. So yeah, also it's very kind of subjective. Mesh reduction is very subjective. It depends on what you expect to get out of it, why you're doing it, and all those kind of things. So yeah, I just sort of skipped over it. But now I am coming back and covering it a little bit. Yeah, so like I said, there's many different reasons why you might want to do it, and each of those kind of, you know, lots of different sort of case studies I could do, which make it really long, and this is probably going to be long enough anyway, so I'm going to limit it to probably the most common reason why you would just want to do a mesh reduction in Simplify3D, and that is that you've downloaded a complicated part off the internet somewhere, a complicated mesh that you can't really edit the actual source 3D file. You just got a mesh, and in order to print it out you just need to reduce the complexity of the mesh. So that is what I'm going to sort of focus on really in this video, and also sort of discuss a little bit at the end why you may want to look at alternatives for mesh reduction. So anyway, let's get on with it. Okay, so let's start off with what I think would probably be the most likely scenario for you to be wanting to use the mesh reduction in Simplify3D. And that is probably going to come about because you have downloaded a fairly complex model from the internet, probably something organic that has many polygons, and you wish to simplify it to speed up, make life easier, and speed up the slicing and therefore the printing. So what I've done, because most of the parts, like I said, that I actually make are mechanical parts and by their nature usually fairly low in polygon counts, I've downloaded a part from Thingiverse that I will link in the description notes. And so let's load that in here. It is a part of a skull. And we are in version 3 at the moment. Now if I zoom in so we can have a close look at this and look around it, you can see that it is indeed quite a complex part with many surfaces, many polygons. So this is exactly the kind of thing that you might want to just simply reduce the number of triangles in the model so that you can just go ahead and print it. So in this scenario, really, there's probably only a couple of things you're looking for, and that is the speed at which it can do that mesh reduction, and possibly the accuracy and validity of the model that it produces. Although I guess that really is of secondary importance, because naturally by reducing a model, you are, reducing the mesh, you are obviously taking yourself away from the original, so accuracy may become less important. However, I guess if it's closer resembling the original, then that can only be a good thing. So let's have a look at those two things, and the first thing we'll look at is the speed. So what I'm going to do is I'm going to load the same part in version 3 that we have here, and go into mesh reduction, and we are going to reduce it so that the maximum triangle side is 2 millimeters long. as soon as I hit the reduce button, we're going to start a little timer to see how quickly it completes the task. And you'll see a green bar down in the bottom right down here progressing along as it does its job. And then once it's finished, we'll stop the clock and we will do the same thing in version 4 to see what speed improvements we have. So let's go. And there we go. It's done its job. It has reduced the mesh. It was not actually that fast. If we look around it, it's reduced the mesh, done kind of what we asked. So let's now repeat the same exercise but with version 4 of Simplify3D. So let's import the same model like so. Let's do exactly the same exercise. Let's do a mesh reduction with 2 mil maximum triangle length and click the reduce button. Bosh, there you go. As you can see, it was much faster in version 4 than version 3, and I presume that if that's all you're looking for, then the improvements in version 4 are clear to see. It is much quicker. So that's that thing, that's the speed, and that's probably the main thing that we'll see an improvement on. But if you are somewhat picky about the accuracy versus the original and how good the mesh is that it produces, then well, stay tuned and we're going to have a look. Now, if we were more interested in the actual accuracy of these mesh reductions between version 3 and version 4, well, what we can do is we can obviously compare the output. So what I've done here is I've basically reduced the mesh, well, the same meshes that we saw a minute ago, but I've exported them out as STL files, and I've re-imported them back into the build plate or bed or whatever you want to call it in Simplify3D, and put them side by side. As you can see, they are very similar, obviously, but they are also quite different. If you have a look at the teeth at the front, around the front here, there are some quite big differences really when you get to meshes. Now, if this really matters to you, then well, yeah, there's more to be said. If it doesn't really matter to you, then that's about it. But you can see they are very similar, although different. And really the only way we're going to be able to sort of quantify how different they are, and I suppose accuracy would be how far they deviate from the original, we can do that in Mesh Mixer. So let's open up Mesh Mixer and take a look at what we've got. So here we are in Mesh Mixer, and here is the original. Here's the original model. Now what I've done is, like I said, I've exported out the resulting reduced mesh files from both version 3 and version 4 as STLs, and I've brought them in here and I have aligned them to the same position. So if we open up the object browser, so we have the original here. This is aligned to a point in space, and if I turn that off and turn this on, you can see this is the STL that was produced from version 3. Now we're going to get back to these red lines in a minute. For now I'm going to turn them off. Where are we? Turn that off so that we can see just the mesh by itself. So that's version 3. If we turn that off and turn that on, that is version 4, and you can see they are all aligned to the same position as the original. So here's the original again. Now if I turn on that and the version 3 version, they are now both overlaid on each other, and if I select both, I can do a analysis and a deviation analysis. Now this will come up with 1 mil, which is probably a little bit big. We'll be interested in something a bit less. So let's show anything, let's highlight anything which is 0.5 millimeters away from each other, i.e. deviating from the original in either direction. And you can see that we have this map here. So anything that is red is further deviated from the original, and this, don't forget, is version 3 mesh. So yeah, we'll do that for version 4, and then we'll overlay them both so we can have a look at the difference between them. So I'm just going to let this animation play. It's literally just switching between the version 3 deviation from original and the version 4 deviation. And as you can see, actually the version 3 is closer or has less deviation from the original than version 4. So the immediate conclusion would be, well, version 4 isn't as good as version 3, apart from obviously that huge gain in speed. But the thing is, this is based on obviously an algorithm that does this mesh reduction, and the success, or success is the wrong word, but the resulting mesh is likely to deviate between version 3 and version 4 in very different ways depending on the model you're doing. So what I'm going to do is to prove that somewhat is we'll do the same exercise but with a different model, and we can see that in fact in that model version 4 deviates less from the original. So for the second example, I wanted to create something which was, while still sort of high polygon, was a little bit more uniform so that we could sort of see more you know, what the deviations are when Simplify3D does its mesh reduction. So in Blender here I've created a model that is essentially quite uniform. It has a number of different peaks which are all the same height across the board, and then, you know, there's just a few different rows of those. I have created it so it's a very high poly model, which we will now bring into Simplify3D and try the mesh reduction on it, and hopefully we should be able to see, you know, differences between these peaks will tell us, well, something about how the mesh reduction is working in Simplify3D. So I exported that model from Blender as an STL file, and I'm going to import it into Simplify3D, and we're in version 4 here. So let's import that in, and there it is. It's what is it, just under 48,000 triangles, so it's not extremely high poly, but it's high enough for us to do some work with. So what I'm going to do is exactly the same as before. I'm going to do a mesh reduction on this with 2 mil maximum triangle length, and there is that there. And I'm going to do the same in version 3. Export both of those as new STL files, bring them into Mesh Mixer so we can compare the two. Here we are in Mesh Mixer, and I've imported the original that we're looking at here, and I've also imported the STL that was created from mesh reduction in version 3 and version 4 of Simplify3D. I've aligned them all to the same point in space, and at the moment we're just seeing the original. If I turn on the visibility for the version 3 model, you'll see that it is overlaid with the original. So we're going to do the same thing again. We're going to select both of those, and I'm going to do an analysis deviation on those, and we'll take it down to 0.5 mil and bidirectional, and you can see that we have some well, deviation obviously. Again, the redder the color, the further it deviates from the original. So I'm going to do the same exercise as before, export this out as an image and overlay it with the same thing but with version 4 against the original, so we can compare those two. So once again, I'm just going to cycle between the version 3 and version 4 deviation, and it is again very close, but I would say in this case the version 4 version is slightly better than the version 3 one, mostly around the sort of peaks of these highest points here will deviate from the original somewhat less than version 3. However, at the front here there is slightly more deviation. So the point really here is that both version 3 and version 4 do a reasonable job of, you know, giving you the best that it can in terms of keeping the original part's shape whilst reducing the mesh. There are differences between them. Whether one is better than another probably varies from situation to situation. So we'll call that equal. What is clear to see, however, is that version 4 is much quicker than version 3 in doing this. So that's kind of the first two levels, if you like. Now, I'd like to sort of slightly discuss why in my original video, when I skipped over the improved mesh reduction in version 4 of Simplify3D, I said that I just use Mesh Mixer for it. And there's a number of reasons why I do that. And really, again, it's down to the type of parts that I work with. As I mentioned right at the beginning, they sort of tend to be mechanical type objects that are actually designed mostly by me in CAD. Occasionally I may need to meld in some kind of STL into a part, and I will do that in Mesh Mixer. Therefore, any kind of cleanup of the mesh that needs to be done, I do at the same time. So that's kind of the main reason why I use Mesh Mixer. But I want to show you another, not reason, but another thing to certainly be aware of. So let's go back into Mesh Mixer, and at the moment we've got the original model viewing here. So I'm going to turn that off, and we're going to look at the version 4 reduced mesh. From Simplify3D version 4, the mesh that it's produced, and an STL export of that. Now, a little while ago when we originally imported a model, it had some red lines on it which I turned off. I want to return to that again, so we put show boundaries on, and what these red lines are showing is basically incomplete parts of the mesh. They are either holes or they are non-manifold areas of the mesh, which is not good for an STL. You don't really ever want that, certainly for 3D printing. Now, I have no doubt that you can print out the results of the mesh reduction from Simplify3D. However, if you wanted to save that STL and use it again somewhere else, you are likely to have issues. If you sent this off to an external printers, if you wanted it in SLS, for example, they would probably grumble and complain because, yeah, it has holes all over it basically. So let's have a look at that. If we click on Analysis and Inspector, what it's showing you here is parts of the mesh which are incomplete, and you can actually see if we zoom in, these shaded areas here are not good. So if I try to, and let's stick this to minimal fill, if I try to auto repair this in Mesh Mixer, you can see basically it's gone, it's no good. So yeah, it's not the greatest mesh that Simplify3D is producing, and actually even Simplify3D agrees. So let's take a look. So let's import the original model that we did the mesh reduction on in Simplify3D and in version 4. We saved that out as an STL file, so we'll bring it back in, and this is the one that we did in version 4. Now, Simplify3D sort of gives you some mesh analysis tools under repair. But for the life of me, I can't get these first two to do anything. Basically, if I click it, it says there are non-manifold segments detected and they have been identified on the model. And yet, there's supposed to be some red lines around here somewhere, which I just don't see whatsoever. And the same is true for the self-intersecting surfaces. I also don't really see any identification of that. However, they are there because it tells us so. We can't see them. But if we go further and do repair normals and then do repair flip triangles, yeah, you can start seeing some things falling apart. So let's do the flip the orientations and the remove duplicates and remove orphans, and you see that we end up with the mesh is kind of fallen apart. So I don't think I'm going to labour the points anymore here. There are reasons why I use Mesh Mixer to modify meshes. It does a better job for one thing. It's a bit more flexible. You don't have to reduce the mesh on the whole model. You can just, literally draw in where you want or select parts that you want, and it just suits my workflow much better. If you simply just want to, make a very high polygon part lower polygon so that it's easier to print, then yeah, Mesh Mixer does it. and version 4 does it really quick, far quicker than even Mesh Mixer does. But you just don't end up with very good meshes. So that in a nutshell is that. So long story short, version 4 produces similar results to version 3 but much quicker. So version 4 beats version 3, so that's good news. To look into it a bit deeper, if you really need to do that, then both of them produce fairly poor meshes, and if you want to produce a proper manifold mesh without any holes, then you'll probably need to look at other software, but you'll have to decide whether that's something you need to do. So I did go ahead and print out the reduced mesh version of this little weird model thing from version 4 of Simplify3D, and it printed, well, it's an awkward part to print. With the resolution capabilities of my printer, yeah, it's an awkward part to print. But the point being is that although that mesh, had issues, it printed out just fine. So, there's no real reason to go any further. If you just want to reduce a mesh, print out the part and be done with it. Yeah, so there you go.